Okay, in this second part of this chapter, we're going to be learning about linear inequalities. So we'll be taking a little bit of notes and doing some practice. So a linear inequality is different than a linear equation because instead of seeing an equal sign, we're going to be seeing an inequality symbol. So remember that we have 4 different symbols: less than, greater than, less than or equal to, or greater than or equal to. And a linear inequality is like a linear equation because it has x and y still, but instead of having an equal sign, we're going to be seeing one of these 4 symbols. So a linear inequality, so some examples would be, for example, y is less than 2x plus 1. So instead of seeing an equal sign, we see one of the 4 symbols: less than, greater than, less than or equal to, or greater than or equal to. The goal is to find the solutions of linear inequalities, and the solution to a linear inequality is an ordered pair that makes the inequality true. So, for example, determine which ordered pairs are solutions to the linear inequality below. You would take this inequality that they give you, and you are going to replace in, for the first problem, 2 for x, 5 for y, and see if it works. So we say, does 2 times 2 minus 3 times 5, is that less than 15? So 2 times 2 is 4, 3 times 5 is 15. Is 4 minus 15 less than 15? So 4 minus 15 is negative 11. And since negative 11 is less than 15, the answer is yes, that 2, 5 is a solution. So for the next one, you're just basically putting in these numbers for x, and you're putting these numbers in for y to see if it's true. 2 times negative 1 minus 3 times negative 7. So we have negative 2, and then this is going to be plus 21. Is this less than 15? Well, negative 2 plus 21 is 19. 19 is not less than 15, so the answer is no. So that's basically how you figure out if ordered pairs are or are not solutions to inequalities. Go ahead and pause and try the next 2. All right, so we would take 2 multiplied by 3. Minus 3 times negative 4, see if that's less than 15. So this is going to be 6 plus 12. Is this less than 15? No, because that's 18. 18 is not less than 15, so no. Let's try 0, 0. So 2 times 0 minus 3 times 0, is that less than 15? Well, 0 minus 0, yeah, that's going to be 0. 0 is less than 15, so that would be yes. Now, the whole point in finding solutions to linear inequalities is not just getting a bunch of points like this and seeing which ones are or are not solutions. It's actually by graphing linear inequalities. So in order to graph linear inequalities, we have to follow a couple steps. And the whole goal is to find the solution region where all the points are that are solutions to that system. So first thing we have to do is put the inequality in slope-intercept form. So it brings back a ton of stuff from the last chapter, we're in the same chapter really, but the last section, this is like solving a system of equations with graphing. All of these problems have to be graphed in order to solve. So be sure to remember you flip the inequality symbol if you ever have to multiply or divide by a negative number. So this happened when we were in the inequalities chapter, like way back in like September or October. But don't forget, if you ever have something like this, like negative 2x is greater than 4. If you ever divide by a negative, you always flip the sign. So this would end up being x is less than negative 2. The symbol does flip around when you divide or multiply by a negative. So when we graph the line, we use a dotted line for less than or greater than symbols, and we use a solid line for less than or equal to or greater than or equal to symbols. A dotted line is like a straight linear line, but instead of it being like colored in all the way, you like leave little dots, or you can use dashes instead. Whereas a solid line, those are the lines you're used to making from graphing systems of equations. All right, and then when you're shading, you shade above the line for greater or greater than or equal to symbols, and shade below the line for less than or equal to symbols. For example, the example that they give us is not in slope-intercept form, so the first thing we have to do is take this inequality, which again, it's an inequality because the less than symbol, not the equal to sign, and we have to solve it for y. So this brings back all of our skills we already have. We know how to do that. Let's subtract 2x from both sides. We get negative 3y is less than negative 2x plus 15. And then this is the first example that we see, and we're already having to flip the sign, because once we go to divide by that negative 3, don't forget with inequalities that you flip the symbol anytime you divide by a negative. So it's going to be y is greater than, and then this is going to be positive 2/3 x, and then 15 divided by negative 3 is negative 5. This is the inequality that we have. It's like an equation. Only difference is the symbol here. Because the symbol is not an equal to anymore, that just requires us to figure out which line to use and which area to shade. Well, we're going to plot the points like we normally would for a regular line. We start at -5, 1, 2, 3, 4, 5 on the y-axis. And the slope of this is positive 2/3. So that means we go up 2 and we go over 3 to get another point on the line. Now, because this symbol, this greater than symbol, is not a greater than or equal to symbol, that means that our line will be dotted or dashed. You have two options. When you make your line, you can make it dashed like that. Or when you make your line, you can just use like dots. You can still use a ruler to make it perfect. You still should be using arrows to show it keeps going, but the line is not going to be colored in like this, like we're used to doing. And that's because none of the points on this line are actually solutions, because this line says that the solutions are anything greater than the line. Anything greater than the line means anything above the line is the solution region. So altogether, this would be your final answer. You would need a graph, you need a line, your line is dotted or solid, and then you color in, you shade in the area that represents the solution region. Any point in this area above the line is a solution to this inequality. For example, let me just point out one. Let's use this one right here, 0, 0. If I use 0, 0, for example, and I replace a 0 in for x and a 0 in for y, I'm going to get a true statement. 0 minus 0 is less than 15. Yeah, that's true, because 0 minus 15 is true. All of the points in this region are all solutions to the inequality. So that's how you graph them, which is basically how you solve them. So the directions for all of these examples here are basically graph the linear inequality to show the possible solutions. If the inequalities are already in slope-intercept form, perfect. You don't have to do anything to start. You would just go ahead and start this one at your y-intercept, -5, 1, 2, 3, 4, 5. Make your point. And then from here, you go up 1 over 3, make your second point. But just be careful, because we're so used to connecting these points with solid lines from the last unit. But this one, because it's a greater than, I know that this is a dotted line. So when I connect these points, connect it with spaces in between. The symbol is greater than. That means the solutions to this inequality are anything above the line. So the solution region would be above the line. When I go to do number 2, and I started at -1, and I go down 2 over 1 to get to the next point, I realize two things. Number 1, less than or equal to means it's a solid line. So when I connect these points, I'm going to connect it with a solid line. And I also notice anything less than or equal to it is anything below it. So looking at this line, anything below the line would be the solution region. So what I would like you to do, please, is finish the practice problems on these pages to make sure you understand how to graph inequalities before you try the IXLs.